29, the hydraulics, and here we can see the hydraulics system on the A320. It has three main systems. What we call, in terms of acronyms to remember, if you can remember God bless you, you can remember the green, blue, yellow, God bless you, in terms of the three systems that exist on the 320. So the green system is supplied by an engine-driven pump. So there's a hydraulic pump on the left-hand engine with an engine-driven pump here. And the yellow is supplied by an engine-driven pump here, and also by an electric pump when the engines are not running on the ground, for example. The blue system is the smallest of the three, and it has exclusively an electric pump that comes on automatically at the first engine start. Okay, so that runs continuously in flight all the time. So we have at the end of the day, during a normal flight, green hydraulic supply from the left-hand engine, yellow hydraulic supply from the right-hand engine, and blue hydraulic supply from the electric pump that runs continuously as long as there's an engine running. And in terms of an emergency, we talked about the Ram Air Turbine. There is a hydraulic pump on the Ram Air Turbine, so that if we have an emergency situation where the Ram Air Turbine deploys, the propeller of the Ram Air Turbine will turn to supply some hydraulics for turning a constant speed motor generator, which will then provide electrical power to the aircraft in an emergency. Don't forget, the RAT is only there in an emergency if we lose all electrical power supply. Okay, in terms of the electric pump, it's supplied, as you can see here, from the yellow system. So on the ground, for operations purposes, to open the cargo doors, for example, to do anything we need to do that involves hydraulics, we need yellow and maybe also other systems. So if we needed green, for example, and yellow, then this can be achieved by this power transfer unit here, which is I call it a pump motor construction. You can see the two parts of it here: pump, motor, motor, pump, pump, motor, motor, pump. So it shuttles between whichever side has the lowest pressure, a difference of 500 psi, and that's where you get what we call the barking dog, because the side that's the pump pushes the pressure one way and to the motor, and when the pressure drops, the other one becomes the pump, and pressures to the other side, and what you get is that barking dog, that woo 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 woo, as it shifts from motor to pump, pump to motor. And it does that continuously on the ground because there's only one electric pump. However, with one electric pump, sorry, not that one, this one here, with one electric pump, we have 3,000 psi in the yellow, so yellow pressure, and via this PTU, 3,000 psi in the green system as well. Okay, so we use predominantly the yellow and the green for ground operations, for flaps, for flight controls. There are situations where we might need all three hydraulic systems. So we'll see in a minute. We can override the automatic function of this by switching the blue electric pump on if required for maintenance and test purposes. Okay, in terms of indications, this is what we've got. So we talk about the lower ECAM, the system display. One of the ECAM system displays is the hydraulics page, which shows here very clearly the three systems: the green system, the blue system, and the yellow system, with their respective quantities in the reservoir. And you can see here It's nothing other than a needle on a stick. It's just like your fuel gauge in your car. It's a needle on a stick, and it's green because that's all the pilot is interested in. Don't forget, guys, we use these system displays. Okay, we use them to perform maintenance, but they are predominantly there to provide the pilots with information that they need in order to fly the aircraft. For a pilot, this needle on a stick indication is adequate. It's green, it's showing midpoint. That's good enough for the pilot. But for me, for maintenance, if I need a more accurate reading, I have to seek other sources of the hydraulic quantity indication. But in terms of pilot indication, this is good enough. Okay, so we can see on the green engine 1 and the yellow engine 2, we have these so-called fire shutoff valves. Okay, the fire shutoff valves, they're devices that will cut the hydraulic if the fire handle is pushed. Then we have a picture of the pumps. So we have a yellow pump. We also have an electric supply here into the yellow system. We have the blue pump, and we have, there's no green at the moment. There's no green. That shouldn't really be there. I think they put it there for aesthetics because there is no green pump. Okay, that would be if you want the engine-driven pump. Okay, we said green is supplied while from the engine when it's running, or from the PTU here when it's active, and the pressure is supplied. The yellow pressure is supplying. Okay, and the nominal pressure is 3,000 psi, and the green arrows here are showing that there are 3,000 psi available, and the green means that my flight controls are being powered. I have power to my flight controls. It's all very what they call ergonomically outlined. And just like we looked at the electrics page in the previous discussions, the picture we have here fits exactly on the overhead panel, so that it's ergonomically well designed and easy to follow for the crew, and thus reduce their workloads. Here we see that panel, and you can see here the layout of it. So we have an electric pump on the yellow side with the normal configuration of if it's this one's different. If it's off, it's black. If it's pushed on, we get an on indication, and if it's faulty, we get a fault. However, if we press it and engage the yellow pump, yellow hydraulics will supply here the PTU, and if the PTU is in automatic function, it will allow the green system to be supplied by 3,000 psi of hydraulics. Okay, so with this method, we use one pump to supply two systems. The third supply here, this is the blue system, and it has the automatic function. Remember the automatic function where it supplies via an electric pump blue hydraulics upon first engine start automatically, hence the word automatic. This one because it has the auto system here, we can switch it off at any time. So a running pump, it will run. Okay, and we have to physically switch it off. Same with the engine-driven pumps. Okay, they don't have an on function, on push button, because as soon as the engine's turning, hydraulics is being supplied because it's connected onto the gearbox. But we can disconnect it here. Disconnect the supply. And in the blue system, okay, we have here the rat, okay, where we can remember these red covered red covers, which mean, guys, think twice before you operate it. Once you lift the cover and press whatever's operating behind that cover, it's a one use only. The rat will deploy. There's no restowing it in flight. Okay, so the rat is connected to the blue supply, which is the standby, which is the emergency, which is it's for emergencies, because the rat is for emergencies. It's the one unit where we hope to never have to use, either in maintenance or in flight. Okay, because it means if the rat is deployed and supplying electrical power, there's not much electrical power coming from any other sources. We also have, again, the fire panel just above, where we can shut the fire shutoff valves or disconnect hydraulics. Okay, I'll just go back one page a minute, and just to show you. So if the fire handle was operated, this one here, if that was operated, then this valve, the respective valve, you can see it's green and in line. It would go green and crossed line. Okay, if the fire handle was pushed or the push button was pushed, and therefore this 3000 psi would diminish down to 0, because the fire shutoff valve has been activated, and therefore the hydraulic supply has been cut off. We also have, other than the main hydraulics panel here, which is on the overhead panel 49 VU, we have on 50 VU, which is further aft, on the maintenance and test panel, okay, the ability, remember we talked about the blue overriding function of this automatic function here of the blue system. Okay, so if we're on the ground and we're performing maintenance and the aircraft is in the hangar, there is no way to operate this blue pump, because this blue pump can only work if you start an engine. Okay, you can't start an engine in the hangar, but I need the hydraulic supply from the blue system. So what do? So I override here, this switch, it's got a cover on it as well. I override the automatic function of this. Okay, and by switching this switch on, I'm supplying now the blue system as well, or supplying the blue system in order to perform maintenance. I also use it as well when I do my emergency generator test, because the emergency generator needs blue hydraulics. Okay, so if I ever need blue hydraulics in maintenance situations, then this is the button I'm going to use to operate the blue hydraulics. We did say it's a maintenance panel, and we did mention previously that this panel is situated really, really at the back of the aircraft, right in front, right forward of the cockpit door, out of the reach of the pilots, because it's used for maintenance only. And therefore, we have it out of the way of the pilots so they can't touch it, because we don't want them to be performing maintenance activities while operating the aircraft. Okay, it's out of the way. It's out of sight, out of mind for the pilots, and it's located in a location that's not easily accessible. To access it, the pilots have to physically get up out of their seats, and they're not going to do that in normal flight. Now, also in this maintenance test panel, there are these so-called leak measurement valves, okay, for the green, the blue, and the yellow system. Okay, in the olden aircraft, the first generation 320s, we did actually have a leak measurement valve circuits where we could measure the leaks, physical leaks in the green, blue, and yellow system for the left, right, and aft parts of the aircraft for the flight controls. Okay, that proved that system was installed on the original aircraft, the first, say, 1,000 aircraft, because they wanted that facility to be able to monitor these things. The hydraulic system proved so reliable that They didn't have much use for this as a leak measurement valve, as a testing facility. But there is another very good function of this, which we use in maintenance every day, which is these leak measurement valves. They cut off the supply of hydraulic to a particular flight control. Oh, sorry, to the flight controls. So any flight control that's operated by the green hydraulics. Okay, if we switch this switch to off, we cut the green hydraulic supply to the flight control. If we press the blue button, we cut the blue supply to the flight controls. If we press the yellow push button, we cut the yellow hydraulic supply to all the flight controls. And this makes the aircraft more safer when we're conducting maintenance. It enables more people to work on the aircraft at the same time. Because if you, for example, you're in the cockpit, you have to do a test on the landing gear. You need hydraulics to do the test on the landing gear. But there's a guy working, he's replacing a spoiler. Okay, so the idea is that you need green hydraulics to perform maintenance on the landing gear, but he doesn't need hydraulics, he or she doesn't need green hydraulics, because if the flight control is supplied, it could move and hurt somebody. So by operating these leak measurement valves, we can lock out the supply to the flight controls and induce safety in the system, so that more and more people could work on the aircraft at the same time without delays happening, people having to wait for the other guy to finish his job before I can do my job, and it works better for the whole constellation. Okay, so that's the idea of the leak measurement valves.